Hello everyone, welcome to Wisdom Trainings. In this video we'll be talking about big data, what big data exactly is, and why do every company is really concerned about it and want to implement the same in its business, right? So this video covers module 5 from the website. So if you go to the website hadoopbigdatatutorial.com, you'll find this video here under module 5. So all the topics that are listed here are covered in this video. Okay, so let me take you back to the slides here. So before we start with the big data, we'll be talking about what data is. I'm sure you must be knowing about what data is, but just to have a connect and to take the things in the right direction, in the same direction as what I want to be, I want to start with what data is and how do we classify the data, and then at the last we'll be talking about the big data definition and that how do we define big data to be. Alright, so I have a picture of a car here, which is a Bugatti Veyron, which is the world's most expensive car. Alright, so what data is? So data, anything, any fact or figure that tells us the qualitative or the quantitative or the descriptive part of an object can be considered to be as data. Alright, so let me annotate it here. Okay, and this is a car. We'll be talking some descriptive, qualitative and quantitative parts and how do we define them as a data, right? So I'm writing it here, the quantitative parts first. Alright, so what's the quantitative things that you can tell about this car? It has 4 wheels, right? So it has, let's say, 3000 cc of engine. Alright, and it has 4 doors. I'm just taking a normal example. I'm not just going into the details of the car here. Okay, so let's talk now about the qualitative part here. So what are the qualities of this car? Okay, so it is very fastest, I can say fastest car. Alright, it is black in color, most expensive. Alright, so these are the qualitative parts of, or the qualitative facts and figures about this car. So all these things can be considered to be as data, right? So all the things that I've written here can be clubbed as data. So these are the data. This is the data about the car Bugatti Veyron. Alright, so any fact or figure or qualitative or descriptive part about an object can be considered to be as data. So this was about data here. So how do we classify the data? We have 3 types of data, that is structured data, semi-structured data and unstructured data, right? So let me start with the unstructured data. So data which doesn't conform to any data model, that is, it doesn't have any data type, specific data type, and it cannot be easily understood by the computer program. For example, you have your videos and audios and text messages and email bodies, images. So all these things do not have any kind of specific kind of data type, right? And these cannot be easily understood by a computer program. So there are these kind of data, that is memos, chat rooms, PPTs, images, audio, videos, etc., can be clubbed under unstructured data. If we talk about the semi-structured data, it doesn't conform to a data model, but it certainly has a structure. For example, if it is an XML file or an HTML, there is some structure, but it doesn't conform to any data model. So if we talk about the structured data, it is in the form of rows and columns with the definite data types. For example, row A will have only string data type, row B can have only numeric data type, right? So that kind of stuff comes under structured data, right? So it's in the form of tables, that is rows and columns, and there is certain relationship between the entities of data. So if we talk about the percentage of the distribution of digital data, nearly 80% of the today's data is unstructured data that comes from the various sources. For example, social networking. Okay, you go to Facebook, you post your photos, you post your videos, you write the comments. So all those things comes under unstructured data, because there is no certain data type associated with that stuff. So you have some certain video, you have certain image, you have certain comment, you have certain status there. If you talk about the Twitter, you use certain hashtags and all. Okay, so you talk about the Instagram, all these stuffs, they have the unstructured data, so that cannot be classified under some kind of data type, right? So though nearly 80% of today's data comes from the unstructured, or we can say it's an unstructured data, and it comes mostly from the social networking. You have the sensor data, you have the GPS data, right? So all these sources are making unstructured data to this amount, nearly 80%. So if we talk about the structured data, it is 10%, and similarly semi-structured data, which is also the 10% of the whole total data that is available today. Okay, I'm talking about distribution of the data here, right? Now moving further, if we talk about the structured data, let me just annotate it. Okay, so if you talk about, you have column names such as employee number, employee name here, and then you have designation, department number, contact number. There is certain data type defined with each of the column, whereas it's written here employee number can be varchar with 10 with a maximum of 10 characters. If you talk about the employee name, it has maximum 50 characters. The data type is same, but if you see the constraint here, it's a length constraint here. Designation can be only 25 in number of characters. Department number can be 5 number of characters, and similarly contact number is 10. Okay, there are certain constraints as well on each of the column name, where primary key is employee number, designation cannot be null, and contact number cannot be null. Okay, so if I go down and look at this, so employee number E101 solely software engineer, department is D1, and contact number is given. Alright, similarly employee number 102 is Mike, he's a consultant, and department number, he belongs to department number D2, and his contact number is mentioned here. So this kind of data, which is in the form of rows and columns, is called as structured data. And examples or the sources of structured data is Oracle DB, MySQL, Teradata, right? So structured data, databases such as Oracle DB2, Teradata, MySQL, and moreover spreadsheets can be classified under structured data. Okay, moving on, if we talk about the semi-structured data, it doesn't conform to the model that we already discussed. So what are the types or the sources of the structured data? You have XML, you have other markup languages, and JSON. So if we talk about the XML, I am sure you must be knowing, but just to write it, and just to, for those who doesn't know that. Okay, so JSON looks like it's a key value pair. For example, I'll write here name is Alan, right? His occupation is, he's an engineer. Alright, so this kind of stuff is JSON. So it has some structure, it's a key value pair, but doesn't conform to any data model. Similarly it goes for the XML file. You have certain tags you can write here, XML, and then you have closing tags, and you can write here anything like name is Alan, then you close, you have the closing tag, then you write here occupation, right, and then you write here engineer, and then you specify the closing tag. Alright, and then you close the XML main tag. Alright, similarly goes for HTML as well. You have your HTML also written under semi-structured data, or can be clubbed under semi-structured data. Alright, so it has some structure but doesn't conform to any data model. Okay, so moving on, let's talk about the unstructured data. So it doesn't conform to any predefined data model. Structure is quite unpredictable. Few examples are written here. So you have a Twitter message feeling miffed, you have a Facebook post wherein you write certain expressions, that is LOL, that is laughing out loud, see, and etc. You have log files, web server logs, you have application server logs. So all this stuff, and moreover you have email bodies wherein you write anything. Hey, Eric will deliver our first lecture today. So this kind of stuff, it doesn't have any kind of structure. Moreover, it doesn't conform to any data model. So all this stuff comes under unstructured data. So there are methods to handle and analyze and take care of the structured and semi-structured data. But what about unstructured data, right? So you cannot really store and analyze and process the unstructured data very easily. Okay, so moreover, it has become the most important share. It holds the most important share in today's digital data. Alright, so if we talk about the sources of unstructured data, again here you have web pages, you have images, freeform text, videos and audios, body of an email, text messages. All this comes under unstructured data, and we need certain tools, or we need certain technologies which can take care of unstructured data very well and process them. So you cannot have something which processes your videos, images, etc. right? So until now we don't have, but now we'll see that in our course what we have for this all stuff. Alright, now how do we deal with unstructured data? You have data mining techniques, you have natural language processing, text analysis, noisy text analysis. A lot of research is going on these fields as well, right? Okay, so this was about unstructured data. Now let's talk about the big word, which is the big data. Okay, so if I have to define it in a single line, what do I write here? What do I speak here, or how do I define it? It is, big data is a term for data sets that are so complex and large that traditional databases or data processing applications are inadequate to process or analyze or handle them. So data has become so huge, so volume has increased to such a great level that processing the data with the older version or the older applications that are available, or the old databases that are available with us, has become inadequate. They have been proven inefficient in handling such a large amount of big data. Okay, so if I talk about few facts about the big data, you'll be amazed to read and listen to these facts. Every minute we send 204 million emails across the globe. 204 million emails, sorry. Generate 1.8 million Facebook likes, sent 278,000 tweets, and upload 2 lakh photos to Facebook in a single minute. I'm talking about in a single minute. And coming to the next important fact, Google alone processes on an average over 40,000 search queries per second, making it over 3.5 billion in a single day. Around 100 hours of video are uploaded to YouTube every minute, and it would take you around 15 years to watch every video uploaded by user in one day. Can you see the amount of data and in the time that it is being generated or uploaded? Right, so it is, I mean, huge. It's humongous stuff, right? Coming to few other facts, the New York Stock Exchange generates about 1 terabyte of new trade data per day. Facebook hosts about 10 billion photos, taking up 1 petabyte of space. The Internet Archive stores around 2 PB of data and is growing at a rate of 10 terabytes per month. So public datasets such as Amazon Web Services, that is AWS, where the data can be freely shared with anyone to download and analyze. So these are the stuffs that we have, or the facts about the big data. So I specified that you can specify big data by a term which is large and complex, which is which cannot be handled by the traditional databases. So there are certain challenges in handling big data. So what are those challenges? I'll just write it here. Okay, so the very first challenge is, how do you analyze this kind of data, which is so humongous and it is coming at such a huge speed and fast rate? Okay, how do you capture the data? Another important stuff. How do you search something from that data, and how do you store the data? Very important, because it has become very huge. Very volume has gone several million times actually. How do you transfer the data, and how do you query the data? So these are some of the challenges that are being faced in handling the big data. Alright, so we talked about this big data, but what is the actual definition that has been specified or mentioned by the experts here? Okay, we'll see all these challenges and how do we overcome that. We are talking in this video about just big data, and these are the challenges that we face. We'll be talking about these challenges in the coming modules. Alright, now talking about the definition given by the experts. So big data's definition, it is a 3V. Actually it is 3V, which is volume, velocity and variety. What do you mean by volume, right? So data, it has crossed zettabytes, exabytes, right? So huge amount of data is getting generated, huge amount of data. So huge volume of data, or huge amount of data, you can say. Right, if you talk about the velocity, from batch processing or batch data to streaming data, in fraction of seconds a lot of data is getting generated. Right, so for example, if we talk about NASA's satellites, they take millions of photographs throughout the day, and each second they take multiple photographs of the Earth. Right, so the data is getting generated in fraction of seconds. If we talk about streaming data that we deal with, it's Twitter. Right, so within a second, there are hundreds of billions of tweets. If there is some event happening across the world, so people will start tweeting. That's the kind of streaming data that exists on social networking. Then you have variety of data. You have your structured data, which is also increasing. Then you have your semi-structured, and moreover the major player here is unstructured data. Right, so as per the Gartner, big data is high volume and high variety information assets that demand cost effective, innovative form of information processing for enhanced insight and decision making. So big data is 3V, and there's another V here which is called as veracity, which takes the big data to 4 V's. Okay, so it's the messing of the data, messiness in the data actually. This is called as veracity. Messiness in the data. There are certain fields that can be missing, certain column is missing, so there's kind of the data is messy around. Okay, it's messing everywhere. All right, for example, Twitter, you use certain hashtags and all, so data has it's a kind of messy. You cannot tell that this can be classified under this data or this, so it's all messy around. So that is another V, which is called as veracity. Right, so this is the big data's definition, which is a 3V. all right, so here we have a wheel here. So variety, which is from structured data to it has gone to semi-structured and unstructured. From velocity, earlier the data was in the form of batch, now it has become the streaming data. If we talk about the volume, from terabytes it has gone to the zettabytes. Okay, so this was about the wheel, or the 3 V's, that is variety, velocity and volume. Okay, now we have a huge amount of data, so but that whole of the data is not so valuable. So there can be some data which is not valuable for us, so we need to extract the data and find out some information from it, and then perform some processing there and perform some actionable intelligence and come out with a better conclusions and enhance our business values. So we have here a huge amount of data. We extract the information from here. All right, So you have a huge amount of data, you do some extraction, what you do is you eliminate the unwanted data and take only the valuable data. Valuable data is extracted. Then you perform some actionable intelligence, that you do some logic or algorithm is defined here. Right, and this is actionable intelligence, which with the output of which is you get some conclusions. Okay, so with the help of which you can perform some better decisions, and you can make some better decisions which will ultimately enhance the business value of your company. Alright, I have few examples here. For example, sentiment analysis, then you have fraud detection. Okay, then you have in the election strategies. Okay, so these are a few of the applications of big data analytics. What you do is for example, if it's a company, it's a product based company, what it does is it will collect the data from various sources, that is social networking, from the data that is available with them of the customer, and will club the data and analyze the data and come out with the better services and products what actually the customer wants, right? So fraud detection, okay, in certain parts of the world, big data analytics has helped in the fraud detection. It can detect for prior of handling having a fraud there, right? So there was credit card fraud, so which was prevented because of big data analytics. The experts were able to get that now the fraud is gonna happen, so they prevented that fraud based on the big data analytics. In action strategies, there are certain examples that I'll be giving you here, right here, where the big data was used to strategize the elections, and it was proved to be a winning hand, right? Okay, so moving on, characteristics of big data. You have volume, which is in the terms of gigabytes, petabytes, zettabytes, exabytes. Now you have variety, that is structured, unstructured, and semi-structured. Velocity, from the batch processing to the streaming data. Okay, here you are seeing 4 different pictures. The very first picture is of Narendra Modi, who is the Indian Prime Minister, and second picture you are seeing is of Barack Obama, the President of the United States. Third picture here is of Amir Khan, who is a Bollywood superstar, and the fourth one is 2014 FIFA champion, that is Germany team. So they all have one thing in common, that is big data analytics. Alright, so all of them have used big data analytics to change the game in their fields. For example, in 2014 elections in India, Narendra Modi's party, Bharatiya Janata Party, used big data analytics to target those voters where their party was not strong, and they were able to crack down the loopholes in those areas, and it proved out to be a winning stuff for them. Similarly, Barack Obama used the same in his election strategies. Very popular show in India is Satyam F. Jayate. So the host and producer of this show is Amir Khan. So he used big data analytics to cover various aspects of social stigma that is happening in India, right? And if we talk about the Germany, they used big data analytics to know the the loopholes of the opposite team, and they were able to hit at that point and were able to win the elections. They were able to win the game, right? So they have big data analytics in the common for them. So why is big data analytics important? So big data can unlock significant value by making information transparent. Big data allows ever narrower segmentation of customers and therefore much more precisely tailored products or services. Sophisticated analytics can substantially improve decision making, minimize risk, and unearth valuable insights that would otherwise remain hidden. So big data can be used to develop the next generation of products and services. So these are the this is why the big data analytics is important, right? So all these persons have used all these have used big data analytics in their fields. Companies across the globe are using big data analytics to enhance their business value, okay, to enhance the customer experience. Even the big data analytics is being used to find a cure for the cancer, to find early infections in the infants. Facebook is using big data analytics to enhance the customer experience or user experience, right? So it is using the face detection, and it is able to tell who all are your friends, and can be tagged, right? So I'm just telling you about few examples here. If you go to internet, and you'll find millions of blogs about the big data, right? And you can study them. All right, so this was all about big data, what big data is, and why big data analytics is very important. All right.